Hi and welcome to this short video, charge controllers for solar panels / wind turbines. In this short video I'm going to be answering two questions. Where does a charge controller fit into a solar / wind system? And what does a charge controller actually do? So let's get started. Where does a charge controller fit in? I've drawn here a schematic typical of schematics that you'll see all over the web actually, and certainly if you've seen my previous video you'll have seen this diagram. We have, well, from the top we have the solar panel or the wind turbine. Its job of course is to generate power. Our battery's job is to store that power. We have an inverter there to convert from the low voltage DC provided by the batteries, to convert that to 110 volts AC to 30 volts AC depending on where you are in the world. To convert the power ready for our electrical appliances, and the job of the electrical appliance is of course just to work. As I said, it's a common enough diagram, but it has the slight disadvantage. Well, it has the advantage of course that it is a nice simple diagram. It has the disadvantage that it's actually too simple. It's simplistic, and although it can work under certain limited circumstances, in most practical applications it is in fact too simple, and we have to introduce something else into our diagram. Actually, it's here that we need to where we need to do some more work at the interface between the thing generating and the batteries storing. So let's make a bit of space, and the missing link in our diagram is, and no surprises for guessing because it is after all the title of this video, the missing link is a charge controller. And superficially anyway, or certainly its main job is of course to charge our batteries. So generate, charge, store, convert, work. So what does a charge controller actually do? Well, it turns out several things. Some of them obvious, some of them less so. Job one, I suppose, is to charge the batteries. I'm sure you didn't see that coming. And it is a case where you pays your money, it takes your choice. The better charge controllers do a better job of charging batteries. And a buzzword to look out for here is pulse width modulation, PWM, on the better models. Perhaps a less obvious function of the charge controller is to enforce a one-way street in terms of current flow. We want the current to flow from our solar panel / wind turbine to the batteries. We do not want it to happen the other way around. Of course, if it happens the other way around, that means that our batteries are being discharged. We also need the charge controller to protect the batteries, protect them from being overcharged, protect them from surges in voltage that might fry them. We also need the charge controller to do the right thing when the batteries are charged, and different charge controllers do different things when they get to the point where the batteries don't need any more current. So the first, and I suppose the easiest thing for a charge controller to do, is to switch off, and that's absolutely the appropriate response if you have a system using solar panels. The charge controllers that work in this way are known as series charge controllers. The other thing that a charge controller can do is to actually keep going, keep drawing current from the supplying device, even when the batteries are fully charged. And this is what you would like to have in place if you're using wind turbines. A wind turbine should always be presented a load. If it doesn't see that, then there's a danger that it will overspin. So for a wind turbine we want a charge controller that can keep going, and of course it isn't able to provide the current that it's taking to the batteries because the batteries are already fully charged. So it instead directs the current to something that's known as a dump load. And charge controllers that work in this way are known as shunt charge controllers. And as I said, this is the right choice if you're using a wind turbine system. Something that some, and by no means all, charge controllers are able to do is to maximize power from the generating device. The buzzword to look out for here, buzz phrase, is maximum power point tracker, or MPPT for short. They work by allowing the generating device to produce all the power it is capable of producing, and they do this basically by varying the load that is presented to the generating device. Tend to be used mostly for solar panels, They also are used with variable pitch wind turbines, and also water turbines. They tend to be much less suitable for fixed pitch wind turbines because they can't react fast enough to the ever-changing output that tends to be a characteristic of a fixed pitch wind turbine. So let's wrap up with a quick summary of what a charge controller does. Of course, it charges the batteries, also enforces that one-way street to make sure that once they're charged they don't discharge, also protects the batteries from overcharging, from overvoltage. Depending on the well, yes, of course, they do the right thing when the batteries are fully charged, and as we've discovered, the right thing is different for a solar panel than it is for a wind turbine. And finally, your real Rolls-Royce top-of-the-range models are able to maximize the power output of the generating device. So that's it. I hope that introduction to charge controllers has been useful for you, and I look forward to talking to you again very soon. Cheers for now.